Good afternoon, welcome to Maths Live. I've already got some shout outs to do. I've got Heidi, I've got Elliot, I've got Seb, Sam in Nottingham. I'll do a few more in a second. Your starter challenge. Now, a lot of you might not have seen this before, especially if you're in year 3 and year 4. It's a pyramid and you've got to do something to the numbers. So you've got to group something to do with the numbers to go up. I don't want to say a particular word because it'll give it away, but have a look, have a go, and then if I show you this one, you'll be able to have a go at this one on your own. Give you a minute, just have a look while I do some more shout out. Let's have a look. Okay, hi James, hi Harry in Nottingham, hi Hallie Beth, hi Maxwell, hi Tom in Broughton, hi Isabel in Derbyshire, hi Ariana, brilliant, hi Harnek, you don't need to put the answers in the feed because I know there's a lot of different ones. Just getting your brains warmed up, no revision. Just a little challenge just to get you started. Hope you had a nice bank holiday weekend. Wasn't it lovely, the weather on Saturday? Chilly now though. That means you get to wear a jumper again, which is nice. So, let's have a look. These will come up at some point in Key Stage 2. So these are called addition pyramids. And what you do is, you take the two numbers in the groups, and when you add them together, it makes the next number up, and so on and so forth till you get to the top. So for this one, it's 5 plus something, which is 7. We know that's 2. Okay, we can go any which way we like, as long as we're able to go up, then that's fine. You can do 6 and 3, which is 9. We can do 2 and 6, which is 8. Now, we know that 9 and 8 is 17, so that has worked. 8 and 7, so 2 8s are 16, so it's 15. And then adding these two up, so 15, 30, 32. So there's your answer for this one. And for this one, just the same. Just the same. It's quite nice, this one, because it's already given us the whole bottom. So 5 and 5 is 10. 8 and 5 is 13. 1 and 8 is 9. We've already know that 13 and 10 is 23. It's told us that. 9 and 13 is 22. And then 23, is that 23? Yeah, 23 is 45. Okay, so I hope that's right. If you've not seen it before, don't worry. It was just a bit of a brain teaser to start. Right. Fractions. Again this week. I know we did fractions a few weeks ago. Might have been a while ago actually. We did decimals and fractions and percentages. So it was quite squashed in, and there's so much you can do on fractions, and this is what you guys requested, so I'm really glad you did. And you're definitely going to learn a lot this week. Even if, again, I always say this, I don't expect you to go away from these lessons and get it 100%, but even if you get it just a little bit more than what you've known before, you might not have seen it at all before. There you go. You might have got some of it, but not quite got all of it. It's fine. It's great. Okay. Today we're doing equivalent fractions. Equivalent means the same. So when we get a fraction, you're looking for a fraction that is the same as the fraction you've got, or in some way you need to change fractions so part of them are the same in order to compare them. I put a note on my page saying how important today's lesson is, because you need to use equivalent fractions when ordering fractions, adding fractions, subtracting fractions, all different ways. So have a really good go today. So let me show you an example. Half. Okay. Half a circle, half of anything, we know half. 1 out out of 2 parts. But there is a different way of writing half, okay? If you've got 6 sweets and you give half to your brother or sister, that means they get 3 and you get 3. And 3 out of the total of 6. So 3 out of 6 is half, okay? So let's do some equivalent fractions that are the same as a half and see what you notice. You can do half, 1 over 2, 2 over 4, 3 over 6, 4 over 8. And all you've got to notice is that the top number is half of the bottom number. So that's relationship. So these are all equivalent fractions. They all mean, even though they haven't got the same numbers, they mean the same amount. So if I do 2 out of 4, if I split a shape into 4 and shade 2 out of the 4, you can see that that is half. It looks exactly like a half. Another way is just even, so if you were asked to compare, say a half and a quarter, and you're comparing whether they're equivalent or not, and you're ordering them, you know that a half is bigger than a quarter, because if you draw again a circle, okay, you know a half is that, sorry, you know a quarter is that, and you know a half is that, so you already know that a half is bigger than a quarter. That's just your knowledge. You don't have to go into making them the same. You can spot that. Remember the crocodile? The crocodile always eats the biggest number. So, that's the easy way of spotting equivalences. Now I'm going to show you the technique when the fractions aren't as nice. So for example, you might be asked about 2/5 and 3/8. You might be asked which one is the biggest or the smallest fraction. Now, what you could do is try very technically to draw a circle and split them into the parts and shade them, but that's not mathematically correct. It's very, very hard to do, and there's a quicker way of doing it. When you're comparing fractions, you need the denominators to be the same. That is the clearest way to know which one's bigger and which one's smaller when comparing them. You'll know this from adding and subtracting fractions. You can only add and subtract fractions when the denominators are the same. We'll be going on to that this week. The easiest way to do it, I'm going to change colour pen, is changing these denominators so they're the same. Quickest way to do it is multiply them. Okay. So 5 times 8 is 40. So both our denominators now are 40. This fraction is going to turn into a denominator with 40. This fraction here is going to turn into a denominator with 40. How did I make this fraction into 40? What did I do to 5 to make it into 40? I times it by 8. So I need to always do the same to the top as the bottom of the fraction. So 5 times 8 is 40. So 2 times 8 is 16. Okay? Now, what did I times 8 by to make it into 40? I times it by 5. So do the same to the top. 3 times 5 is 15. Oh, look how close it is. Look how close it is. That would have been really hard to work out without doing the comparison. So it tells us that 16 over 40 is bigger than 15 over 40. Yeah, do you see? So, right, what have we learned already, very, very quickly, is that the denominators have to be the same when comparing fractions. I'll show you another example. 7 over 9 and 3/5. 7 over 9 and 3/5. How are we going to compare these two fractions? We multiply the denominators. So we're going to do 9 times 5. Okay, 9 5s are 45. Now we've got equal denominators now. What do we do to 9 to times it by 45? We times it by 5. So we do the same to the top. So 7 5s are 35. Okay. What do we do to 5 to get 45? We times it by 9. So we'll do the same to the top. 3 times 9, 1 9 is 9, 2 9s are 18, 3 9s are 27. So that tells us that 35 over 45 is bigger than 27 over 45. So at the end of the day, ignoring this, it's that 7/9 is bigger than 3/5. So you make the denominators the same. Remember that. You make the denominators the same. How do I make the denominators the same? I multiply them and get an equal number. 3 questions. What 3 questions did I give you for this lesson? I asked you in question 1, which fraction is the same as 1/3? Which fraction is the same as 1/3? Is it A, 2/7? Is it B, 3/9? Or is it C, 1/6? Question 2, I would like 2 fractions. I'm just going to put fracts which equal a quarter. Any fractions which equal 1/4, just think of 2. And question 3, I want to know, is 1/5 either bigger, smaller or equal to 2/9? Similar to what I've just modelled to you. Have a go at those if you haven't already done so. I'm going to have a look at the feed now, see what people are saying. Oh wow, so many comments, so many comments. Wow. I can't even scroll back all the way. Hi Keenan in Norwich. Hey. Hi Rio, hi Josh. Brilliant. Hi Lucia, hi Amelia. Hi Jensen. Hi Macy. Hi Daisy and Bridget. Okay, go right, so got some answers. Brilliant. Oh, 50 over 100, yeah, that's equivalent to a half. Brilliant. Super. Oh, someone's made a very good comment. I'll come back to that. Well done. Whoever's on Sophie Allen's account, that's a very, very good question. Oh. Just having a read. Good, well done. Hi Seb, but let's keep comments sensible, Seb. Right, so Lucy, Lachlan, Harry, well done. While you were finishing that, I had a comment about simplifying fractions. Thank you for mentioning that. I'm not going to do that today because this is quite a complicated topic, but I will be doing it this week when we're adding, subtracting, multiplying, dividing. But thank you for mentioning that. Okay, 1/3. Which one of these is it? What you've got to do is look at the denominator, and you'll know that you've got an equivalent fraction if the denominator is a multiple of that number. So you're looking for denominators that are 3, 6, 9, 12, 15, 18. So immediately we can cross out A because it's 7. And 7 and 3 don't fit in together. Now, so it could be one of these two. So let's check. I mean, 1/6, if you have a shape, if you have a triangle, say that's 1/3, you know that 1/6 is actually going to be half of that again, so that doesn't fit in, so it can't be 1/6. So is it 3/9? So what do I do to 3 to make it into 9? I times it by 3. Oh, do the same to the top. Yay, so it's 3/9, that's the answer. 2 fractions equal to a quarter. I could go on forever here, but I'll give you some highlights. Again, you're looking for numbers that are the multiples of 4. So if you made that into 8, it would be 2 over 8. 4, 8, 12, that would be 3 over 12. 4 over 16, 5 over 20. See the pattern? 4, 8, 12, 16, 20, 1, 2, 3, 4, 5. You could have 10 over 40, 100 over 400. There's lots of different ones. And the last one, I just need some space up here. Same as we did before. So we have 1/5 and 2/9. And we need to work out if they're equal or which one is bigger. So 5 and 9, we'll times it together. 5 9s are 45. We already had one that's 45, haven't we? Very similar, we've already done the 5s and 9s. So what did we do to 5 to make it into 45? We times it by 9. Do the same to the top. 1 times 9 is 9. What did we do to 9 to make it into 45? Times it by 5. 2 times 5 is 10. Oh, look at that, it's really, really close again. 9 and 10. So this time, 2 over 9 is bigger than 1/5. Just by 1. 1 over 45. Well done. So yeah, keep remembering, how do I compare them? I make the denominators the same. How do I make the denominators the same? I multiply them together, and then I always do the same to the top of the fraction, the numerator, as I do to the bottom. Challenge time for you guys. Now I'm going to do it 2 questions at a time. I'll do 2 questions, and then I'll see how you're getting on, and then we'll move on. So I'm going to do question 1 and question 2. So 3 over 4, okay, and just trying to see what that is. 8, oh, so 3 over 7. 3 over 4 and 3 over 7. Is it bigger, smaller, or equal? Comparing them. And 5 over 10. Is it bigger, smaller, or equal to 1/2? Let you have a go at that. Well done, Josh. Well done, Amelia. Well done, Lucia. Well done, Adriana. Oh. Just check the second one, Harry. Giving you a clue there. Got some answers coming in. Well done, Harry. Right, not too bad these ones to start. So, 3 over 4, bigger or smaller than 3 over 7. So, let's do, so 4 times 7 is 28, so we're making them so they're both over 28, because you've multiplied the denominators together. 4 times 7 is 28. What did you do to 4 to make it 28? Times it by 7. Do the same to the top. 3 7s are 21. What did you do to 7 to make it 28? You times it by 3. 3 3s are 9. Wow, this one's a lot bigger than this one, so it's like that. So your answer is 3/4 is bigger than 3/7. With this one, they are equal. They are equal, because 5 is half than 10. Yeah? So sometimes you can get the equal sign. So we'll do this one separately, because this does require a bit of calculation. What is bigger? 8 over 10 or 6 over 7? Have a go at that one. Okay, well done, Elliot. Super, well done, Lachlan. Well done, Sam. Oh, got some answers coming in. Right, yep, got some more right. Everyone's agreeing. Okay, let's check. Let's check. So, 10 times 7 is 70. What did you do to 7 to make it in 70? Times it by 10. So do the same to the top. That's 60 over 70. What did you do to 10 to make it into 70? Times it by 7. 7 eighths are 56. So yes, you can see that 60 is bigger. So you'll have that side in between, that sign in between. Right, proper last challenge question now for you. This is going to be tricky. Take your time and just use the same method that you were doing before, okay? Because when you're doing this task, it involves equivalent fractions. So, ordering smallest to biggest. Okay, you ready? You've got 2/5. Let's have a look. 6/10. 12/20, and 1/4. I'm going to give you a clue. Use that. Hi Lucy and Ned. Wow, we all did really well in that last one. Brilliant, well done Kitty, well done Halle Beth. I'll have to give you a little bit more time for this question because it's a bit trickier. Use that. I'm giving you a clue about the denominator that I've underlined. Oh, first answer. Fantastic. Brilliant, well done. So, it's very impressive for a Monday on a new topic. So, I gave you the clue that we should be putting them all as 20. Okay, that was a nice clue to give you, but like I said, it's a new topic. So, we already know this is 12. Okay, So let's go to this one. So what do we do to 10 to make it into 20? We times that by 2. Do the same to the top, that's 12 over 20. What do we do to 5 to make it into 20? 5 times 4 is 20. Do the same there, that's 8 over 20. What do we do to a quarter? So what do we do to 2? So 5 times 4 is 20. So 5 over 20. Now this is the bit you have to be careful of, because you're ordering it from the smallest to biggest, and I've seen this happen a lot. I've seen it where people doing the question forget about these and order these from the smallest to biggest, but it's always the original ones. So the biggest, okay, well, have I made a mistake there? So 12 out of 20. Sorry. So the biggest ones are so small as these two, aren't they? Oh look, they're equal. Well done for spotting them. And then this is the second biggest and this is the smallest. And we're doing it smallest to biggest. Now that's another thing that people get caught out on. Read the question. How many times they do it in the wrong order? It's the simplest part of the question. So the smallest one first is this 5 over 20. So we'll put a quarter. Let's, I'm trying to think, I don't know if you can see the bottom of the board. So a quarter first, done. And then we've got 8 over 20, which is 2/5. Done. And then it doesn't matter which way you put these because they're equal. So you can put 6 over 10 if you like. And then 12 over 20. Let me just see if that is in shot. Just about. It's just about in shot. There you go. So you've used equivalent fractions to compare fractions, and you've used equivalent fractions to order fractions. And like I say, we'll be using it lots this week when we're calculating fractions. Well done today. You did very, very well. I'm going to put a challenge question up for you now, and then I'll see you tomorrow where we are doing mixed and improper fractions, and I love working with those. Very, very interesting, very, very fun. All right, I'll see you tomorrow. Bye-bye.